Welcome to this explainer. Look, today we're unpacking the real economics behind India's water emergency. And honestly, you need to forget what you think you know about droughts. It's not just a weather problem, right? What we're really looking at is a wild story of economic paradoxes, literally sinking megacities, and a super intense race against a very real ticking clock. Let's get right into it.
To really wrap our heads around the sheer scale of this crisis, we have to start right here. The Indian subcontinent supports a massive 18% of the entire global human population. We're talking over 1.4 billion people who absolutely rely on the land beneath their feet to survive, to build, and to grow.
But wow, here is the shocking drop-off. Despite housing 18% of the world's people, India commands a mere 4% of the world's freshwater resources. 4%! That staggering, kind of terrifying structural imbalance, that's the engine driving everything we're about to discuss today.
To make sense of it all, we've structured this as the anatomy of an emergency. We're going to count down to day zero, uncover the great agricultural drain, look at sinking cities and toxic water, explore mega projects and desalination, and finally wrap up with how ancient wisdom is actually meeting high-tech.
So, part one, counting down to day zero.
Okay, let's look at the numbers. Back in 1951, India had a really comfortable 5,178 cubic meters of water available per person. Fast forward to 2021, and that number basically plummeted to 1,486, pushing the nation firmly into what's internationally recognized as the water-stressed category. And the projections? Well, by 2050, it drops to just 1,140. They are edging dangerously close to absolute water scarcity.
So, you're probably wondering, how long is the runway here? Under a business-as-usual scenario, India has about 209 days of water reserves before total exhaustion. But here is the absolutely crucial point. Look at this survival mode thought experiment. If we halted all industrial and agricultural allocations, like just completely stopped them, and used water strictly for basic human domestic consumption, those exact same reserves would actually last 8.75 years. Take a second to process that. Human drinking water isn't the primary drain here at all.
Which brings us to Section 2, the Great Agricultural Drain.
The data reveals a genuinely shocking reality. Nearly 90% of all extracted fresh water in India is consumed by agriculture alone. Think about that. Just 8% goes to industry, and a tiny 3% goes to domestic, everyday human use. That massive 89% chunk is heavily driven by really inefficient flood irrigation techniques, where fields are, well, essentially just drowned in water.
Now contrast that massive water drain against its actual economic contribution. Agriculture consumes 89% of the water, yet it contributes roughly only 18 to 20% of the national GDP. Meanwhile, the industrial sector uses a fraction of the water but generates the vast majority of the economic output. The water intensity of Indian agriculture is just wildly out of proportion with its economic value.
So why is it so inefficient? Well, honestly, it's heavily driven by policy. Get this, it takes up to 20,000 liters of water to produce and digest 1 single kilogram of cotton. 20,000 liters! Rice demands about 3,000 to 5,000 liters, yet highly nutritious traditional crops like millets, they require a mere 400 liters. But government procurement policies heavily incentivize farmers to grow these total water-guzzling cash crops, even in super-arid regions.
But, there's really no one-size-fits-all crisis here. Take Punjab in the north, for example. Their crisis is almost entirely policy-driven. The state gives farmers free unmetered electricity, and when the cost of pumping water is literally zero, it completely divorces extraction from economic reality, right? It's just draining their deep alluvial aquifers dry. Contrast that with Tamil Nadu in the south. Their crisis is geological. Sitting on hard crystalline rock, when they pump too much, the water table doesn't just decline slowly, it plummets completely out of nowhere.
Moving to Section 3. Sinking cities and toxic water.
So there's this really scary phenomenon called inelastic compaction. Basically, when you pump massive amounts of groundwater out of the earth, the hydrostatic pressure holding up the soil layers just disappears, and the ground physically sinks. Recent satellite radar data shows that 878 square kilometers of land across huge megacities like Delhi, Mumbai, Chennai, and Bengaluru are actively subsiding right now. Buildings are literally at risk of structural damage simply because the water holding up the earth beneath them is gone.
And the water that is actually left, it's turning into a bit of a biological nightmare. As these aquifers run dry, they start drawing in geogenic toxins. Because of this, over 70% of India's groundwater is now contaminated. We are talking about 80 million people exposed to arsenic, 120 million exposed to fluoride, which causes irreversible skeletal deformities. Plus, you have massive nitrate pollution from agricultural fertilizers, and, believe it or not, even radioactive uranium leaching straight from the bedrock.
Let's look at Section 4, Megaprojects and Desalination. To buy some much-needed time, coastal cities like Chennai are pivoting to massive infrastructure. They're building the Perur Desalination Plant, which is poised to be the largest in Southeast Asia, churning out 400 million liters a day right from the ocean. But the economics here are brutal. Supplying treated surface lake water costs about 8 rupees per kiloliter. Desalinated water? Up to 60 rupees. It is highly capital and energy intensive. It's a necessary lifeline for wealthy coastal cities for sure, but it is absolutely not a national panacea.
A much more sustainable urban fix, though, is the circular economy. Cities are now taking municipal sewage, running it through advanced tertiary treatment reverse osmosis, or TTRO plants, and then piping that ultra-pure recycled water directly to industrial corridors for machine cooling. In Chennai alone, this brilliant strategy is saving 90 million liters of fresh drinking water every single day. Now that is a game changer.
And finally, Section 5, Ancient Wisdom meets High Tech.
First, the ancient wisdom side of things. The state of Tamil Nadu is actually resurrecting a pre-colonial practice called Kudimaramathu. Instead of this slow, top-down bureaucracy, the state is directly funding local farming communities to physically desilt and restore thousands of historical minor irrigation ponds and tanks. This grassroots approach restores natural percolation zones, basically capturing the monsoon rain and allowing it to slowly seep down and refill those shallow, hard rock aquifers. It's incredibly smart.
Now combine that with a high-tech agricultural pivot. Remember that free electricity problem in Punjab we talked about? Well, some states are piloting save water, earn money schemes. It's an amazing economic quirk. They still offer the free power, but if a farmer uses less electricity, and therefore pumps way less water, the government actually pays them cash directly for the savings. Throw in Internet of Things soil moisture sensors and precision drip irrigation, and you suddenly reintroduce economic efficiency without destroying the farmer's livelihood.
And that really brings us to the ultimate question we have to ask ourselves at the end of this explainer. Can India fix its agricultural economics before the water runs out? The engineering solutions exist, right? The data is crystal clear. But shifting the behavior and economics of hundreds of millions of people, that is the true challenge here. It's a fascinating, critical race against time. Thank you so much for joining me to explore the real mechanics of this crisis. Keep questioning, keep learning, and I'll catch you on the next explainer.